the previous episodes, we focused on how we can use the BoardMaster to safely test discrete components under power-off conditions. In today's episode, we will be focusing on how we can test ICs under safe power-off conditions using the BoardMaster. So Oliver, how do we go about testing ICs in circuit?
Okay, so it's just the same principle as the VI signatures we covered in the last couple episodes. So instead of doing that VI signature between 2 points on the PCB,
Sure.
we're doing that VI signature between a pin and a ground, and between a pin and another pin, so you get to see inside the IC.
I see. So we're using the similar methods, but instead of just testing, instead of using probes or tweezers to test discrete components, resistors, capacitors, diodes, so on, we're using clips.
Exactly. Right? So we're just using a clip instead, and the AMS is already programmed for this feature, so it's just simple as plugging in the cable and the clip and hooking on the IC, then starting the test.
That's great. Can we see a test?
Absolutely. So I'll start it in a VI. There we go. So it's as simple as changing the mode from probe to clip, choosing the amount of pins you'd like to see, and then just hitting start. And it will go across each IC. I'll put it on 2D for now to show you. It's a bit quicker, so it doesn't have to go through that range of frequencies. There you go, stop that. Okay, so that's the 2D VI from each pin to a ground, and I can also run that in 3D as well, which I don't think I've seen on any of the VI tester. There you go. It'll go a bit quicker if you chose a shorter frequency, but again quite a broad range from our pin to ground.
That's great. And as you mentioned, with it being 3D VI, as shown in the previous episodes, we could sweep across the frequency range to see how our IC reacts.
So it's just performs just like the well, it's the same instrument, so it's going to perform exactly the same as you've seen before. I can open up the view here. This is just from pin 1 to the ground, and this is what the 3D image looks like. So we've got our voltage against current, and then backwards we've got our frequency, and we can shift through that with our scroll.
It's fantastic. And again, we can store this information and compare it against another component or another board.
Yeah, so VI is a comparison test. I can show you if you'd like. Sure. I'll show you in a. I'll touch on a test flow. So we'll discuss this in the test flow episode. But for now, I'll just explain that it's sort of a work journal. You just do everything you've been doing before in a test flow, and it records all of that. So I'll just open the same instrument. It's as easy as opening the instrument. So I can just start a test as you've seen. Works just the same. Goes between every pin to the ground, across that frequency. Also in the setting we chose our voltage range and our impedance. You can check the data sheets for more information about that. And we also got VI. We can also do VT as well, but that's for another time. Here we go. We've got all our scans from each pin to ground, and I can store that like we've done before. Store in a mask. The test flow, when you save your test flow, actually saves that mask as well. So when you come back testing the same board, it'll be able to compare that signature against your stored mask.
So just to touch upon that, everything is saved, even the settings and the
Absolutely.
location.
So even when we go onto our MIS4, where it's got oscilloscopes and things, when you come back to your test flow, you don't need to change all the settings and scale it up, scale it down whatsoever.
So it must save you a lot of time.
Absolutely.
Great, fantastic.
So I'll move the reference to emulate another IC.
Sure.
There we go. And because it's a different reference, you obviously get a fail. So this is what it would look like if, say, you had the same board, you measured everything on the golden board, you got a faulty board back, and you see a bit of a burnt IC. So you put the clip on there, and you'll get something like this. Says that
Sure.
IC has been fried.
And then to look at each individual pin, you can select the pin of your choice and then look at it in more detail. Am I right in saying?
Absolutely.
Yeah?
So here we're looking at pin 1 to ground.
Sure.
Got the 3D image as well. And then we can obviously scale through each frequency. We're starting at 10 Hz, and we're going all the way to 10 kHz.
That's great. Thank you, Oliver. Stay tuned for next week's episode, where we will be focusing on matrix VI and how this is different to the VI we've shown in today's episode.